So, hi everybody. Thanks for coming to my session. Try to find a place to sit. Here's one seat in the front that's still free. Thank you very much. So, how are you guys liking the show? Doing great so far. Thanks to our awesome sponsors who made this possible, that we can see each other in person again after 3 years of PSConf abstinence. My name is Evgenij. I come from Berlin. I've been doing Microsoft-focused stuff for upwards of 30 years. I work as a consultant for a medium-sized systems integrator in Germany. I'm a user group lead and speaker, and I have spoken at some conferences before, PSConf including. You can always grab me on Twitter, or you can have a look at my blog, or you can just scan the QR code. I think it's a link to the bio page. So what are we going to talk about in this session? Everybody who's been doing PowerShell in ops encountered the situation where scripts need to be run unattended. And this introduces some challenges that we will talk about in a second. I guarantee you, if you have been doing PowerShell for however long, you won't hear in this session anything you haven't heard before. It's not claiming to be like some kind of best practices session. It's what I call ass-saving practices. These are things that save my ass and that of my colleagues, of my clients, etc. Countless times. As I was younger and got to go to driving school, our teacher, our instructor used to say, the traffic regulations are printed in blood. Think of those as printed in blood. This is what I'd like to talk about here. So, some strategies to avoid your scripts wreaking havoc in your environment, unattended, unseen, unchecked, and some strategies to maximize success of that unattended execution. So what are the use cases we're talking about? These including, but not limited to, good old task scheduler. Most everybody has a task server sitting somewhere that just calls PowerShell scripts via task scheduler. Don't tell me that you don't. Maybe you haven't looked good enough. Log on, log off scripts, shutdown and startup scripts. Many people still use those. Orchestration engines. We have two awesome sponsors sitting outside who do orchestration engines specifically for PowerShells. There are others. There is System Center Orchestrator or vRealize Orchestrator, you name it. Any orchestration engine out there can run PowerShell scripts. GitHub Actions or Power Automate flows. Monitoring. If you need to gather some data from your systems for monitoring, be it SCOM or CheckMK or an Azure's, you name it, sometimes the only or the best way to get to that data is PowerShell. So you have your monitoring agent execute PowerShell scripts on those systems. IDM, identity management. Most identity management systems can create an Active Directory user. Half of them will create an Exchange mailbox. If you also have to create a Skype for Business account or assign a Teams license or whatever else, or to create a personal folder, you need to do some supplementary actions. Backup systems allow you to execute a script before backup starts, on the target machine and execute a script after backup ends. Many people make use of those. And of course, configuration management, many of detection actions in SCCM or MECM, but also in other configuration management or software distribution systems are written in PowerShell, configuration baselines, and so on. Those are the use cases where a piece of PowerShell code gets to run unattended, unmonitored, unchecked. Now, any computing follows the same principle, the hand principle, right? You got some input. It can be an explicit input in form of parameters or implicit input in form of the environment you're analyzing. Then your script does something, that is the put phase, and in the end of that, you get some output. In an unattended execution, if you are not the only person who managed the entire environment, there are things you as the enterprise scripter in charge don't have much control about. The operating system, Rob talked in his keynote about DBA tools not being multi-language capable in the first installments, right? But also addition. Of course, if I craft my script for servers, it may get run on a client operating system. If I do not provide for that case, it may not do what it was intended to do. Underlying hardware, if I'm doing something within my script that relies on the system having at least 4 processor cores or at least 4 gigabytes of RAM, it may not run as intended if the system is not that well equipped. Security context. This is the most important one by far. Some scripts are intended to run a system. Think detection actions. Think detection actions in SCCM or monitoring. Usually those agents run as a local system on Windows or in some equally capable context on Linux. What happens if the security context the script gets started in does not have those privileges? PowerShell host. There was talk about PowerShell versus Windows PowerShell. Yeah, what happens if you target PowerShell and someone decides to drop your script into Windows PowerShell? For each parallel, we'll throw that error we all saw in Sydney's talk. Parameter was not found, right? Because on Windows PowerShell, for each object has not got the parameter parallel. There are custom hosts as well. Any application can create a custom host. If Ops migrates its orchestration from one system to another, they will assume that your scripts run equally well in the target system. That need not be the case. What modules are installed or maybe already loaded in the session on the target system? If you rely on modules being there, your script must do something non-destructive at least if they aren't. Connectivity to required resources. The world today is about talking to databases, is about talking to REST APIs, all this stuff. What if somebody is so impressed by the success of your scripts in LAN that they decide to drop it into the DMZ, where you can't reach those APIs you rely on being reachable? And of course, last but not least, early abort by the invoking facility. If your script needs 2 minutes to run, but the monitoring agent or a configuration management agent that executes it has a 45 seconds timeout, then your script will not get to run all the way. You've got separation of responsibilities here. Your ops will take care of the systems being there. Your ops will take care of the networks being there, of the services being up, of the security context maybe being granted required privileges, and so on. What they will not and should not be taken care about is your script. And that's why your script, if it's geared for unattended execution, has to take care of itself. And that means we need to provide a meaningful output, a meaningful result in any of those circumstances I talked about earlier. What does it mean? If everything works as expected, we need our script, or the invoking system expects our script to provide a certain return code. Many systems will not process the output of the script if the return code is 0. They just assume that everything is okay. And only if we provide a differing return code, then they will assume that something is not okay, although it well may be. Think Robocopy, right? Robocopy provides many return codes. Almost all of them indicate success, but almost none of them is 0. So that's our situation. We need to know what the invoking system will ideally expect in terms of return code. Output in a certain format. If we're working with a Nagios compatible monitoring system, we need to provide that Nagios format with debug level at the front and service description and so on. Or no output at all. Think SCCM, detection actions. As long as there is output, SCCM will assume the application is there or the condition is met, even if you output the value false. And you are expected to clean up after yourself. If you, create an Exchange remoting session to do what you came to do with your script, and you just tear it down you just exit your script without actually disconnecting that session, the imported remote PowerShell module remains on the system. Do it hourly for 2 years, every day, and your disk gets full. If something does not go as expected, first order of business is to leave no unfinished business. Of course, if we're talking about early aborting, your hands are tied. You can't do very much there. But just because you can't do what you came here to do does not mean you need to leave unfinished operations. So roll everything back that you can roll back if you cannot roll forward all the way. Provide an error RC if the invoking system is expecting one. Provide an error output. Again, I worked on an IDM project where the identity management system that was in place would treat any output as error. In this case, green half, no output at all. Red half, then you could provide a meaningful error message because that would pop up as error in the log of the invoking system. Happy days. And provide troubleshooting means if you can. You may or may not log every step locally. It would be a good idea not to delete that log if not everything could be finished successfully. And what in my career that may or may not be true for yours. provide the best results so far is linear execution, one step at a time. You do an init, you check all the prerequisites, you check for an operating system, language, connectivity, modules, assemblies, all this stuff that you need to do what you came here to do. Then you validate an input. If your script receives an input, think IDM. You need to do something with the user account of X. So X is your input. Go ahead and validate if the user actually exists before you go ahead and try doing something to that user. You need to create a VM and put its Active Directory machine account into a certain organizational unit. Go ahead and check if that OU exists in the first place before you start creating object. Input validation, really important thing. Then you do your put phase, input processing. That is basically what you came here to do. And then last step is output, your meaningful output, return code, result objects, and cleanup. What happens if there's something wrong here? You just skip these steps, go ahead and go to the output phase. What happens if there's something wrong with the processing? You clean up after yourself, roll back what you already created or changed, if you can, and then you move to the output phase. And the output should provide the user or the administrator with the means to actually troubleshoot that. And this results in a slightly convoluted structure, but this is basically what a script that conforms to my R-saving practices would look like. You accept some input objects, whatever it is. It doesn't need to be of this type. It can be a string. If it's a username and you know that it will be a username, you can do that. But if you do not know what object the invoking system will pass to your script, it may be a good idea to just accept anything and then sort it out in the script. And you define some functions, the most important of which is the result function, and the result function has the success of the first three phases as arguments, and then whatever the put phase chooses to throw it at. And from this data, we just create for instance, a custom object that contains an output object. That could be a string or an array of strings containing those nages formatted data or anything else. If you think your script will be orchestrated by a script runner, then you need to provide that script runner format and so on. And the exit code, if in doubt, 0 for success and 1 for failure. And what you do in exit is just you get your result by invoking this function and output the output, and then you exit with this exit code. And this being the last line of your script, this exit statement is not going to create any ambiguity as to the order of execution. Right? In the init, you check all permissions, prerequisites, and so on. I'll talk about that in a second. So, just some pointers. Again, it's not a level 500 session, it's R-saving practices. Pre-execution checks, like requires or run as admin, and so on. They are great and interactive. because there is a live person sitting before the console and seeing, hey, this script should have been run as admin, should have been run elevated. Depending on what your script is intended to do, it could take months before somebody actually notices that it hasn't run at all, because you required it be run elevated and it wasn't. Right? So these things, it's up to you. It's up to you. If you know the guys who manage the invoking systems, and you know they do their due diligence, they look at the log, they hunt down any error message that they encounter, etc., then they will see this stuff. If you're not so sure, just drop all those pre-execution conditions and check them in the script. Check them in the init phase. Yes, it takes some code to do, but then you have done your dues. Load modules explicitly and make sure they're loaded. VMware Power CLI will load on Linux and on Windows. If you need Active Directory module, it will not load on Linux. But someone may have copied it to a Linux system. So a simple check if the module's there will return true. It will be listed as available, and if the metadata has not been managed properly, it may even be listed as loadable. And it's only when you attempt to actually load that module that you encounter errors. Include version. If you know that your script will not run on Power CLI 11 and actually requires 12 to run, then include that in the loading statement. And if your admins were lazy and they update Power CLI on 3 of the script execution hosts, but not on the other 2, and they try to run your script there, then it will not run. And they get a meaningful results because you provided for that. Check resource access. If you know you will have to connect to a database or to Active Directory or whatever, REST API, just try and make a connection. At least verify that it's there, that you're not talking over a firewall that will not actually allow that access. Read-write access. We've seen in the keynote the example using assert path. Great stuff. But if the executing context of your script does not have privileges required to actually create that folder, the folder will not be there after assert, right? So how does an init look like? We just define some modules that we would like to import. Here, this is important. If you're using VMware Power CLI, do not import Power CLI. Only import, those modules are all interdependent, but you're importing a bunch of stuff you don't need. It can quadruple your loading time if you just say import VMware Power CLI. Go ahead, do your dues, and research which of the many modules you actually need. Needs to run elevated. It will run it on Windows, but it will not run on Linux or Macs. And it will only run properly in a console host. It will not run in the ISE. It will not run properly in some custom host, or at least you're not sure if it will. So and then you just go ahead and check. You can check for the platform using PS version table, and once you know you are in PowerShell, not Windows PowerShell, then you have nice variables, is Linux, is macOS, and is Windows that have been set for you. I've made it my rule to set it if I am in Windows PowerShell. This way I can always look at those values later. Check host, same thing. If allowed hosts have been set, then check if your executing host is one of them. Check if that's elevated. If you're okay so far and you're running on Windows and you have specified it needs to run elevated, well then go ahead and check if that is running elevated. And then last not least, check the modules. This only checks for the module availability. We will see how loading works in a minute. Do not attempt self-repair. Do not attempt things like a third path when you run unattended. Or do not attempt to install modules if you run unattended. A customer of mine ended up having Active Directory PowerShell commandlets on upwards of 1,000 servers. Because somebody thought, it's a great script, let's run it everywhere. The script checked if the PowerShell commandlets are there, and if not, it just added the RZAT feature. Document the prerequisites clearly. So if you're on the phone with the admin of the invoking system, you can just point them to the beginning of your scripts and say, hey, everything that you need for this script to run is documented there in the header. Whether you output warnings or not depends on what your intended invoking system would do with them if you were, right? It may be not optimal. Some systems actually analyze the warning stream as well. So, we talked about loading modules. This is a good example of what dependencies are. Load third-party modules early. There is a special place in hell for module authors who use write output in the loading part. Every time that happens, God kills a kitten, right? Because so we all know how to actually suppress that. You need to just redirect this loading import module commandlet to null or to a variable of your choice. But the golden rule is no output in script. The only facility that's doing the output is the result function, is the exit function, right? Keep an eye out for that. Module qualified commandlet names. It's a pain in the ass to write. But if you have a mixed environment, you end up with script running hosts having a great variety of modules installed in them. And sometimes there are overlapping commandlet names. We'll see that in a second. Your own modules and includes, like dot sourcing, for instance, they are a double-edged sword. Tobias talked about functionalizing, reuse of code, etc. This is all true. This is all what's made PowerShell as great as it is today. But it increases the number of files you need to have shipped so that the whole script can run. If you know, this is the script. It may have dependencies to third-party modules, or again, it may not. But this is the .ps1 file, and if you give it someone and he puts it into his invoking system, it will run. This is a very comfortable situation for those admins. This is the very comfortable situations for when you get the call from those admins on the phone. Of course, PS Framework is a great module. It takes a lot of complexity out of PowerShell scripting, but it's hard to distribute it everywhere. It's hard to rely on it because what will you do if it's not there? That's your design decision. Let's not look at the module loading because you all know how that works, but I'm on a script running host here where I have installed the Hyper-V module from Microsoft and the Power CLI in the latest version. So what happens here? I check if I can access this command, export VM, and it takes a while, and we also see why, because export VM actually comes from Power CLI. If I would like to check for the availability of the new VM command, it also comes from Power CLI. Now, this is unfortunate because earlier it... no, that's right. Earlier it came from the Hyper-V module. See, there is no consistency here. So if I need to create a Hyper-V VM and I check for this, then indeed I get the commandlet from the Hyper-V module. Same for export VM. So, a word of caution, it doesn't work every time. I can't address export VM in this manner. Does anybody know why it is so? Let me just pull up the previous results. It's not a command. Export VM out of the Power CLI module was an alias. And that's where module qualified command specification is a bit goofy, right? Keep an eye out on that. So, what else may we need to pass to our scripts in terms of dependencies? Configurations. Simple configuration values you can just pass as default values of optional parameters. Where's the value in that? You can change them at execution, you can change them at debugging. Config files, here you need to make design decisions, namely where you place those files. Script path is a great place to pass files you ship with a script. Not as great for things that you maybe manage centrally. Registry on Windows. Some folks still write script configurations into the registry. Customer of mine has great success with that because you can manage that easily with group policy preferences in an Active Directory environment. Of course, the registry is not cross-platform, it's not available on Linux. Or a central configurations provider. This is a very nifty one, a web service that should be authentication free but may require authentication if you're so inclined, that just serves JSON files. A design decision here would be what do the script do if that service is not available? So maybe put it behind the load balancer or something. Credentials were my favorite topic for I don't know how many years, for upwards of 10 years already. Try to not need any credentials. If you do, try the invoking facility try to get the invoking facility to pass you a PS credential object. So that then the insecure storage of credentials is on them, not on you. Otherwise, well, whether you're using a secret management module or roll something of your own or use some other credentials provider for PowerShell script, check for availability, which includes decryptability of those credentials as early as possible. Because if you don't get them, then there's not much point in doing anything else. And in any case, before you start making changes in the environment, check all the credentials involved for their actual validity. Passwords may have changed over time, accounts may have been locked out, whatever. Invest the time, invest the code at the beginning and check all those things. You've seen already some try-catch statements. There are 4 possible outcomes when running a script. All the prerequisites are met and the put phase was successful. All the prerequisites are met, put phase was not successful. It has nothing bad has happened, but you just couldn't achieve everything. So you need to maybe roll back some of the changes that you made. And the other 2, init failed or something unexpected happens during the put phase. So you need to provide a meaningful output for each and every scenario. And this you can achieve by using the results or the exit function as the only output facility. This is basically the most important thing I was planning on talking about. You only have one place in your script that does actual output, and this is the exit function. And exit immediately after providing output, but not before you clean up, of course. Error handling. No unhandled errors in scripts that run unattended, because no matter if you color your error output red or green, nobody will ever see that. Right? So every error needs to be handled. How do you achieve that? You set the error action preference to stop in the very first line. And then you use try-catch clauses for any exceptions that you anticipate. So if you load, for instance, modules that are listed as available, and you put that in try-catch, and if you're in a catch clause, then something went bad with loading one of the modules, right? There may be other exceptions. I mean, you can't just put every commandlet that you invoke in try-catch, right? So the script would become completely unreadable. You could, you absolutely could, but the script would still become unreadable. For that, we have a trap statement. There are folks that advise against using trap, but for scripts where you actually don't know what could go awry, trap is a great facility to actually catch those exceptions that you haven't anticipated. One thing to be wary of when using trap. After trap, the execution will resume. So the best thing to do in the trap clause is to call your exit function. Because That's how you ensure the script does not step any further. Early bug out. I talked about it already. So if you need to break out early, just clean up after yourself and skip all the steps that do not need to be executed. And this may be one of those rare cases where it's okay to access a script scope database connection object from within a function. Just to close that database connection, right? Not to use it actually, to just close it. I will have to skip the demo because we have some content I would like to show in terms of us saving practices. Earlier bought by invoking facility. This is one of those cases you can't do anything about, that just ends. So what can you do as the enterprise scripter in charge? You could try logging state and cleaning up on the next execution. You can try to provide an alert on the next execution that the previous execution was aborted, or whatever, but you need to do something about it. Debugging, a script that doesn't provide any output, is pretty hard to debug and develop. Verbose stream to the rescue. You just do your normal output, but you direct that to the verbose stream. And you can even provide a debugging marker that redirects the verbose to log file, I don't know, a text file, or, for instance, some troubleshooting pointer that tell your script that it is running in a troubleshooting environment. For instance, if it's got started in ISE, that might be a pointer that you are troubleshooting. Or explicitly with a file marker. One last thing. It's easy to monitor success or failure if the script gets to run. You can't do anything, or let's say you can't do very much to help the admins of the invoking system to do their part if the script doesn't get to run. What turns out to be a good practice is to leave a breadcrumb. A small file or an entry in the event logs that just tell the systems and its admins this script got executed. Where to put it, it's a design decision because not all systems can write, or not all execution context on all systems can write to all locations, right? So, what I'd like you to take away from this session, what a meaningful output has to be in each of the 4 execution scenarios. Put that in a function. Check prerequisites first, after leaving the breadcrumb. Prepare generic building block. Here's your code reuse. Reuse your code, but maybe build a CI/CD pipeline or your own script builder. I will provide an example of such a script building script in the snippets that I will upload to GitHub. Whatever you're comfortable with, reuse the functions that have been successful. And that's all for today. Thank you very much. Yeah. Thank you. Feel free to catch me outside.